Okay, so this is a problem I found on MSE, of course, because I'm obsessed with that site. And I think it's like fairly popular, right? Yeah. I mean, you would have seen stuff like on these lines, but I don't know if you've seen something precisely like this. Well, I guess we'll see. Um, yeah, comment if you've seen like something exactly like this, so just that I know that I'm plagiarizing this apparently. But no, it's taken from a site, right? And I found a pretty cool approach to this that should be pretty good. So anyways, the question is, you have to evaluate the following expression: square root of 1 plus the square root of 4 plus the square root of 16 plus the square root of 64 plus, and so on, right? So from here, if you have the slightest of brains, you'll realize that this is actually, okay, let me just rewrite the 1 in a more clear form. This is actually just 4 to the 0, then the next square root, 4 to the 1 plus, then the next one, 4 to the 2, next one, 4 to the 3 plus, and all the way down, right? Now I think there's like quite a lot of ways to show that this converges, but we're just gonna solve for it because that's just, I'd like to do that. Anyways, yeah, so we're gonna use recurrence for this one, which may be a bit of an advanced topic, but anyways, I hope you understand it. So first we're going to define a function f of x n such that it's equal to x plus 2 to the n, right? This is like a multi-valued function, but well, I mean, we'll see where this comes from, right? You'll see. So anyways, okay, so a way to think about how we get here is to say, well, 4 is just a power of 2, right? And we need something, so let's just parameterize it, kind of parameter. I'm putting that in quotes, right? But so yeah, a way to get this like by default, but I guess it's kind of tough to get it like out of the blue. Anyways, let's just suppose that you got this part, right? So anyways, now what we're gonna do is, since we want, well, let's think through why we're taking the steps that we are taking, right? So since we want something inside a square root, what we want to do is create a square root here. So the obvious way to do that would be to square it and then take the square root. And notice that let me just write this: a square root is always greater than 0, well, I guess equal to 2 for all a in the real numbers. Yeah, and that's true because this is always greater than 0, so square root is just taken to be greater than 0, if I'm not wrong, something like that, the explanation. Anyway, so it's this square, right? So let's expand these brackets. So it's a general formula: a plus b squared. I think it's called like the binomial theorem, but this is like the very basic version of it that you're taught in, like, I don't know, class 8, class 9 maybe. Time is just a human construct for me, so I don't remember when I heard about this one, but anyways, it's that, right? Okay, so we let a equal to x and b equals 2 to the n. Anyways, we're just gonna plug those values in. So then we x squared plus, we'll note that 2 times 2 to the n is 2 to the n plus 1 times x plus 2 to the 2n, right? That's like 2 to the n squared, and so this just comes down here, 2 to the 2n. But notice that I put the bracket here, so yeah, just beware of brackets. So now what we're gonna do is take out the x, right? And we'll just, well, because we know that this is within the reals, we're gonna switch the order of addition, which we can do. So we're gonna do that, and then factor out the x, and then we're gonna get x plus 2 to the n plus 1. Now look at this, and then look at this. I hope you've noticed something. This is just brilliant because it is f of x comma n plus 1. Yeah, and brilliant, isn't it? Like, great. Anyways, yeah, this is really neat. So from this point on, what we're gonna do is we're gonna do a very basic kind of recurrence thing that you don't even need to know the name of recurrence for, right? So yeah, we're gonna do it in a really basic manner. We're not going to like do any advanced stuff. So yeah, notice that this is f of xn just to finalize it, right? So let's check what's f of x comma n plus 1, right? So what people will do is like say let n be n plus 1, but that's confusing and I am an official person, so we're gonna say let n be j plus 1. Yeah, because I like j. I don't know, jg is good. So anyways, x comma j plus 1, right? That's just going to be equal to the square root of 2 to the 2 j plus 1 plus x remains the same, notice that. Then n plus 1 becomes j plus 2 f of x comma j plus 2. Yeah, now we plug this back in here. So now our f, and of course notice that j is just a random variable. That's just a name we've given to something, so we can just call that j and n, it doesn't matter. So we're going to plug that in here and we get that f of x comma n is equal to the square root of 2 to the 2n, then we have plus x, then we plug in this value, so the square root of 2 to the 2 n plus 1 plus x. I'm gonna rub these off and I'm gonna skip a step or two, right? So you see that this exists here, but now we can do the same kind of thing with this that we did with this, and we can just expand that, and you can keep on going infinitely with that stuff. So what you do is you just, so you see a pattern, right? So you go here, okay, so it's just square root of 2, then this is n plus 1, right? So we'll have 2 n plus 2 plus x, and notice that I'm just going to keep extending the roots until I'm satisfied, and then you know what, yeah, I think I'm satisfied. Yeah, I'm just gonna do dot 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 there. So hopefully you understand where that came from, right? Again, this may be something that may go a bit over the head of some people, but I hope not. Like, this is, I tried to explain it the best way I could, even like, create some intuition for this idea, although it's like intuitively not that intuitive, which, yeah. So I just learned the word intuitive, by the way. Anyways, so we see that f of xn is equal to that expression. Notice that our initial expression, what was our initial expression? I wonder. But anyways, okay, so let's create this, let's make this, yeah, I know English, more familiar form. So that 2 to the 2n can be written as, okay, just make sure the camera angle is nice, 2 to the 2 to the n. Notice that 2 squared is 4 to the n. So we're going to use that everywhere here, right? So we're going to get that 4 to the n plus x times square root of 4 to the n plus 1 plus x, and then I'm just going to do dot dot because I'm lazy, right? So now you should be able to see what I'm going to do next. What do we want here in the first term? I want a 0, right? Clearly. You know what? Let's wait, right? Let's have some patience. So let's first remember that our f of xn originally was x plus, I just hit the 2n, right? And that's a 2, not a z. So yeah, that's the thing. 2 to the n. Yeah, people really don't understand my handwriting sometimes. Anyways, pain aside. So look at this and then look at this. Now look at this part and look at our original question. Do you see something similar? I hope you do. So if we set x equals 1 and n equals 0, this expression is exactly equal to this one. So let's just do that, right? X equals 1, n equals 0. So x equals 1, so that's 1 plus 2 to the 0 is equal to, okay, let's call this n because I don't want to write that out again, is equal to n. And n is finally equal to 1 plus 1, which is 2. Now, yeah, let me just mention here that a to the 0 is equal to 1 for all in the real numbers. Yeah, that's fine. So yeah, that was a very neat proof, right? Proof, more like a very neat problem, a very neat way to show that recurrence can give you things that you think are like, like this looks, like look at this, right? Look at this. Ignore everything I've done here and look at this. This looks divergent, absolutely divergent. It's just gonna keep increasing. Like a normal person wouldn't expect that to end anytime soon. But yeah, here we've proved it ends quite soon. Anyway, so yeah, that was, yeah, I really did like that. But anyways, so yeah, my parents could be home any minute, so yeah, that's pretty nice. Hopefully you like the video. Yeah, I don't know, nice. Quick side note, I just remembered, if I say nice, then I have to mention something related to 6 9. So 2, yeah, that's a 2. So notice that if we take ln of n is equal to ln of 2, which is approximately equal to 0.69. So yeah, now it's nice.